trig functions, products and quotients. But we haven't done the derivatives of, like something if I said 3x plus 1 squared. The only way we were able to do that derivative was by multiplying it out. However, there is a way to do this derivative without first multiplying. That's our chain rule. So when you have a function inside a function, right? So we could have written that 3 times. I tried to put it in terms of u, but even if you think of it as like, I'd said 2x minus 3 cubed. Okay, you could multiply it all out and do power rule, or you could say that's the same thing as doing 2x minus 3 times, right? And then the product rule says you do one derivative at a time. So derivative of the first one, the other stays the same. Plus derivative of the second one, the other stays the same. Plus derivative of the third one, the other stays the same. Do we agree with all this so far? When we look at this, this is u prime times u squared. This is u prime times u squared. This turns into u prime times u squared. So we have 3 identical terms. So it turns into 3u squared times the derivative of u, or du dx. In other words, what it's telling me is this derivative, if I did it, would turn into, the 3 would come down, my function, so 2x minus 3, squared, so that's really just our power rule, times the derivative of the inside. What's the derivative of 2x minus 3? 2. And so this would turn into 6 times 2x minus 3 squared. That's the chain rule. You basically do the derivative of the outside, inside stays the same, times derivative of the inside. So that's what this is saying right here. When you have a composition of functions, derivative of the outside function with the inside function remaining the same, and then multiply by the derivative of the inside. So if I asked you to do this one, I would not want to multiply this out 17 times. I would not want to write it 17 times and do the product rule 17 times. That would be way too time consuming. But our chain rule says we can do this derivative by doing the derivative of the outside. The outside is something to the 17th power. So when you do that derivative, the 17 comes down, inside stays the same. If you subtract 1 from the power, it's now to the 16th. Then you have to multiply by the derivative of the inside function. What's the derivative of 3x squared plus 5? 6x. All right. Simplifying, you could do 17 times 6x. So 102x times 3x squared plus 5 to the 16th. Another way you might see this written is like dy dx is dy du times du dx. These really aren't just separate fractions. This is representing the derivative of y in terms of our function, the derivative of the inside in terms of our function. So just keep that in mind. Those, when you see dy dx or something, it's representing a derivative or a rate of change. It's not really a true fraction there. All right, so let's look at this one. So if I wanted this derivative, what would I need to do first?
You could change that to parentheses x squared plus 1 parentheses 1.
Is there any way I would be able to simplify that so I could just do a power rule or something? Can we take the 1/2 to each piece? No. So we have to do the chain rule here. So chain rule, derivative of the outside. What's the outside?
1/2.
the 1/2 power. So power rule, exponent comes down, inside stays the same. Subtract 1 from the power, so 1/2 minus 1 is negative 1/2. Times derivative of the inside. What is the derivative of x squared plus 1?
2.
2x. So then if we simplify, 1/2 times 2x will just give me x times x squared plus 1 to the negative 1/2. Let's look at this one together. So this applies to our trig functions as well. The biggest thing is deciding what's the inside and what's the outside function when you're looking at that. So, A, what is my inside function?
Square.
The x squared. Think about if you plugged in something for x, would you do sine or would you square it first? On this one, you would square it. So, that's the inside. Chain rule says you start with the outside. What's the derivative of the outside? So the derivative of sine is cosine. The inside stays the same, so it's the cosine of x squared. Times, then we do the derivative of the inside, which is 2x. So we just get 2x cosine of x squared. 1b. Sine squared x, what that means is you have the sine of x squared. So this time, sine is on the inside. We start with the outside, which is something squared. So how do we do the derivative of something squared? Chain. So the 2 comes down, inside stays the same. Subtract 1 from the power, so now that's just to the first, times derivative of the inside. The inside is my sine x. What's the derivative of sine x? So that's just 2 sine x cosine x. All right. Are there any questions on those? Do you see the difference between the two? Your book has a theorem where it states the power rule with the chain rule. That's what we have been doing, so it's really nothing new. I want to take a look at this problem together, and then I'm going to have you try some on your own. So an oil refinery makes U liters of gasoline from X barrels of crude oil. Then they make Y grams of petrochemical from the U liters of gasoline. Identify the units of each of these things. dy du, du dx, and dy dx. So I'm asking for units here. Remember, these are all just representing derivatives. Derivatives are rates of change. So, if we look at the top, what's the units on y?
Grams.
Grams. Per. My denominator was u. What's the unit on u? Okay, so grams per liter. All right. So if I ask for the unit of du dx, what would that be? Liters per x was in grams. Alright, and dy dx, what would that be?
Grams per meter.
Because y is in grams per x is squared. So as we interpret derivatives, units are important. Think of it as just your rate of change, something per something. Any questions there? I want you guys to try a couple. So I'm just going to give you a few minutes. You could probably do the next like 4 if you wanted to try that. So the first one, y prime or dy dx, the 100 comes down, inside stays the same, subtract 1 from the power, so the 99, times derivative of the inside, which would be 3x squared, so you get 300 x squared times x cubed minus 1 to the 99. Looks like we did well on that one. This one. Okay, almost everybody had the same wrong answer written down here. So your exponent comes down. Inside stays the same. Subtract 1 from the power, so it's -4, times derivative of the inside. What's the derivative of the inside? Okay. So then you could multiply your -3 with that. If you did that, you would have to distribute the -3 through this parenthesis. I can only combine those two because they don't have exponents, right? This middle parenthesis has an exponent, so I can't. So if I distribute that, I get -30x plus 6. But that's wrong. Why?
You get our negative, actually, so if you get 30x plus 6 divided by 5x squared minus 2x plus 5.
Okay, that would work. There is another way of writing it, but this way would be a correct answer. How is this not actually equivalent to that? What did I miss? Let's take a little side note then. What if I gave you one with smaller numbers? So if it were like 2 times x plus 3 times x minus 1. Okay? And if you multiply those two things, so you get 2x minus 2, and wrote it like this. When it's written that way, you would only be distributing the -2 through this parenthesis, right? Yeah, it's this whole thing times that parenthesis. You have to put that in parentheses because, like in this example, I would have to FOIL the 2x minus 2 and the x plus 3. So parentheses matter. That's the thing that most people left off. Writing it as a fraction takes care of it because it's the whole -30x plus 6 divided by this. Or you need the parentheses around it, one or the other. But that is probably the most common mistake with the chain rule, is not putting it in parentheses when you have multiple terms there. Does everyone see why those parentheses are necessary? So on this one, did pretty well on this one. Our derivative, so 3 comes down, inside stays the same, subtract 1 from the power, times, what's the derivative of the inside?
5.
-5. So then you could take 3 times -5, so get -15 times 2 minus 5x squared. Okay, and the last one, you could do quotient rule here. I'm guessing you probably don't want to. It would be easier to write this as 2x cubed minus x plus 7 to the -2 power. So then our derivative, the exponent comes down, inside stays the same. Subtract 1 from the power, so now it's -3, times derivative of the inside, 6x squared minus. So again, you can multiply these two things, but what do I have to put? Parentheses, so it would be -12x squared plus 2 times 2x cubed minus x plus 7 to the -3. Or you could write the 2x cubed minus x plus 7 to the third on the denominator. Alright, so on my simplifying, I'm just multiplying things that don't have exponents together to clean it up a little bit. Any questions for me? I'd like to do one more, and then that'll be probably where I stop today. All right. So if I start doing my chain rule, this one's uglier because I have a fraction within it, but the general premise is the same. We do the derivative of the outside. So my 5 comes down, inside stays the same. Subtract 1 from the power, so it's now to the 4th. Times derivative of the inside. To do the derivative of this inside, what do we have to do? Quotient rule. So low, d high. What's the derivative of z minus 1? Minus high. D low, derivative of z plus 1? Over low squared. So now we're just in the cleanup stage. We have 5. If we wanted to, we could write this as z minus 1 to the 4th over z plus 1 to the 4th. That might help us cancel some things out in a second. Okay, here we have z plus 1 minus z plus 1 over z plus 1 squared. So my z's cancel. 1 plus 1 is 2. So then I could go ahead and multiply this together. So if I multiply the tops, I get 10 times z minus 1 to the 4th. If I multiply the bottoms, I get z plus 1 to the 6th. So you might have to do a combination of quotient rule and chain rule, or we could do product rule and chain rule. All right. Questions on this? We are going to keep practicing tomorrow, but I want to give you guys some time to practice and ask questions today. So I posted a handout on Classroom. I think it's 10 problems for you guys to try. Ask if you need help, and you can definitely check them too.